Today's drones can't get close to structures because of the way that they move. So they have to lean forwards or backwards to move forward or backwards. But as the drones start to get bigger, they have a lot of inertia associated with them. So leaning takes a long time. They either get blown away from an asset or blown into it. It just doesn't provide that, inch or centimeter level of control that you really need with a drone.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 363. Can an old technology make industrial drones safer and more effective? For that question, we travel to Boise, Idaho, to speak with Zach Adams, co-founder and chief engineer for Pitch Aeronautics. Pitch Aeronautics has developed a unique drone for up-close, touch-based robotic tasks. Among the most dangerous jobs in the United States is climbing infrastructure to perform inspections and maintenance, as well as performing powerline maintenance. While today's drones are good at taking video, they are not well suited to get close or actually interact with the surface of an object. Consequently, technicians are sent up on ropes, ladders, scaffolding, cranes, and sometimes even hanging from helicopters to perform the work. Pitch Aeronautics Astria Drone is specifically optimized for touch-based tasks. It has a unique configuration that can hold a 10-pound payload on a long horizontal arm to keep it away from the rotors and allow it to interact with a building, bridge, tower, wind turbine, or power line. It's flown to the area using a first-person view camera and goggles. Astria then overlays key flight and job information onto the goggles so the operator can conduct the mission. Astria positions the payload near the target by using a cyclorotor for lateral control. Cyclorotors are unique propellers that can near instantaneously push the drone forward, backward, left, or right. This allows Astria to compensate for wind gusts and fly more precisely. It can create and change thrust 5 to 10 times faster than traditional drones. Cyclorotors have been used on tugboats and ferries for nearly a century for the same reason. Zach is recognized as a leading authority on cyclorotor technology. He is the name inventor on multiple cyclorotor patents and has published extensively on the topic. He holds a BS in Aeronautical Engineering from the U.S. Air Force Academy and a PhD in Mechanical Engineering from Purdue. In this episode of the Drone Radio Show, Zach talks about Pitch Aeronautics, its innovative Astria drone, and how the company's patented cyclorotor technology is making dangerous jobs safer. But before we hear from Zach, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. I especially want to thank my recent supporters, Jeff Voigt, Carter Lemire, and Murnal Kumar for their donations to the show. It is greatly appreciated. And by the way, if you have a great story on the use of drones that you'd like to share on a podcast, contact me at randy@droneradioshow.com. So let's learn how an old idea is making drones safer and more effective with Zach Adams of Pitch Aeronautics. Let's pick up the interview where I asked Zach to introduce himself.
I'm Zach Adams. I'm co-founder of Pitch Aeronautics. The technology that we're doing now comes out of my doctorate from Purdue, back when I did that.
Zach, what is Pitch Aeronautics?
We're a company that is making a drone to do up-close, touch-based, and robotic tasks. It turns out that the most dangerous job in the United States is being a climber. So not like a rock climber, but a tower climber or a bridge climber. These guys have fatality rate of about 1 in 100 in a 10-year career. And that is more than 10 times the rate of construction workers. So it is extraordinarily dangerous. These guys are getting out there on ladders, scaffolding, they're hanging from helicopters, doing really outrageous stuff to do this industrial maintenance. I think everybody thought that drones would supplant, kind of the tasks that these guys are doing out there. And while they're able to help a lot with the visual portion of it, it turns out that what a lot of the climbers are doing is up close and touch based, where they actually have to interact with the surface. So we set out to design a platform specifically to be able to address that problem and perform up close and touch based tasks.
So other drones that are doing bridge inspections or cell tower inspections, they're just doing imaging. They're not interacting with the structure itself.
Yeah, and that speaks to kind of a larger theme in the drone industry overall. Drones today are highly optimized for remote sensing. So they're really good at video. Some of the LiDAR stuff they're doing now is really spectacular. But what they can't do is they can't reach out and physically interact with the surface. And a lot of the types of things that these guys are doing require that. So an example would be using an ultrasound to see how thick a pipe might be, or taking and using a crack card to see exactly how wide a crack is on a concrete or steel bridge. And those tasks you can't get a sense of from a video taken from far away.
What did you come up with that was different?
Well, before I get there, it's probably relevant to explain why today's drones can't do it. Today's drones can't get close to structures because of the way that they move. So they have to lean, that is pitch or roll, forwards or backwards to move forward or backwards. And, you can do this pretty quickly for a very small drone, but as the drones start to get bigger, they have a lot of inertia associated with them. So leaning takes a long time. So if a gust of wind comes along, even if it's just a small wind perturbation, it takes those drones a long time to spin up their motors, change their orientation to stay in exactly the same place, and they just can't do it. So they either get blown away from an asset or blown into it. It just doesn't provide that inch or centimeter level of control that you really need with a drone. My doctorate was on a new type of propeller called a Cyclorotor. I say new because the research has just enabled them to be able to be efficient for aircraft, but that concept has been around for almost 100 years. What this propeller does is it provides, it looks kind of like a paddle wheel on a paddle boat or a vertical axis wind turbine, and it provides near instantaneous thrust vectoring in a 360-degree plane. So it can provide thrust forwards or backwards or side to side and change that very, very quickly, near instantaneously. And that allows you to make a platform more precise in lateral control. So where they're being used today is on tugboats. So they put them on tugboats so you can precisely position a ship in a harbor, or on ferries so that you can precisely come up to the dock to allow cars to drive off. And we're doing the same thing with drones to be able to move precisely relative to another object.
The drone doesn't look like your typical drone. To me, it looks like a praying mantis. It has a long arm, some familiar drone propellers, but there's also something extending vertically from the drone. Is that the Cyclorotor?
Correct. So the Cyclorotor is that thing on top, the top center. And that's a very different type of propeller that helps with the lateral control.
And this is a better design because the drone doesn't have to, as you say, lean into an object?
Yeah, absolutely. You can have the thing be perfectly level and then still, move back and forth or side to side via the Cyclorotor. And because it doesn't take any time for the Cyclorotor to change its thrust, it can do it so quickly. But you bring up a couple of other things that might be interesting. First is Mantis was actually a name that was proposed for the drone, just because of the way that it looks. We ultimately settled on Astria, which is the Greek goddess of precision. The whole point of it is to be precise. So we settled on that, but I can see how it looks a little bit like a praying mantis, and that's kind of has these long, skinny arms. But the look of it, it's not just the aesthetics, it's a very utilitarian purpose. The form fits the function here. So on this particular configuration, we have a payload. You can be 5 to 10 pounds, and in the future, even more. So a substantial payload that goes way out on this arm that keeps the payload totally out of the way of all of the propellers of the drone. So instead of having your payload on the bottom of the drone, you can have your payload way out on this arm, so that you can interact with the vertical surface. So imagine, you can take a drill and go up and put a hole in a wall, or you can take a whole bunch of bird diverters and install them on a power line, or you can take an active thermography sensor, one of our sensors here, to get it close to be able to heat an object and then take thermal images of it. And that payload weight there is balanced by a very large battery, a very, very large battery on the opposite side of our drone, so we can keep it in the air just as long as possible.
From the images on the website, this isn't a small drone. How large is it?
Yeah, the length depends on what the payload arm is, but it's about 9 feet long and 6 feet wide and weighs just under 40 pounds with the payload. So this isn't any toy. It's a big industrial object.
You mentioned that Astria can touch and interact with the physical environment, but what sort of practical applications does that translate into?
We drew all of the types of payloads from interviews with customers and started designing them from that. So one thing the customers are really wanting to be able to do in industry that they couldn't do today is they said, could you just put a ruler up next to a crack so we could take a photo and get a idea of the scale of the thing? Because when you take a video from a traditional drone from far away, you might see that a crack is there, but you have no way of identifying how big it actually is. So we did them one better, and we made a special sensor, a crack width measurer, we call it, and it uses a computer vision camera and a distance measuring device. And if you take a picture from 1 to 3 feet away from a crack, it can spit out the exact width of all of the cracks that are in the image by an advanced algorithm that's on the device. So that allows the inspector that's using it to characterize the width of a crack and how it changes over time, if it's growing or if it's not growing. Something that today would have to be done by rappelling down and putting a crack width measurement card. This kind of looks like a business card with a bunch of different varying widths on the card next to the crack, and then write down in a notebook, how wide the crack is. Whereas with this configuration, we can fly up next close to the crack, take the picture, and characterize all of the different widths that are on the crack. Beyond that, another task that is pretty common is to try and detect subsurface delamination. Now, that's a big way of just saying there's damage that you can't see from the surface. So on bridges, the face or side of the bridge can delaminate from the rebar that's under it. And that can cause a hazard damage that can fall down, or it can cause a structural problem if it's left to go too far. And on wind turbines, this is actually the leading cause of wind turbine blade failures, is there be delamination between the composite layers. And if that's allowed to go too far, the whole blade can fail. Same for large commercial aircraft. So we have made an active thermography sensor. This is a device that's commonly used in aerospace inspections in the factory, but it uses halogen lamps to heat up the surface of an object. And then you take a series of thermal pictures, infrared pictures. And from the heat flow through the object, you're able to detect subsurface defects that are not visible from the surface. But you can't do this from far away because you actually have to heat up, the side of the object. So our drone allows to position this, this sensor close enough to be able to perform that type of inspection. In the future, there's a whole bunch of different things that we can do. So one thing that's up and coming right now is the installation of bird diverters. So these are small plastic devices that are kind of like reflectors that are put on power lines, particularly over like marshes or over rivers, to prevent migratory waterfowl from hitting the power lines and getting killed. I guess millions of birds are killed every year from this. But today it has to be done via helicopter or via bucket truck on these live electrical lines. It's super dangerous. So we're designing a payload arm to be able to put bird diverters on in combination with a partnership with another company and the university. But you could also do ultrasound measurements. You could eddy current detection, maybe even repairing holes. Any up close or touch-based robotic task is what will come into being a reality with this platform.
That's really interesting. Just recently, I saw a video where a huge swarm of birds rested on a power line. There were so many birds that the weight caused the line to snap, resulting in a big electrical discharge.
Yeah, I'm learning more and more about them as we identify it as a problem. But from the power company guys, it seems like it's a really big issue. That's a problem all around the world.
What's the battery life for the Astria drone?
Battery life is always an issue for all drones, I think. And that's why we designed our drone the way it is. So we designed it to be much larger than a traditional small drone, in part to carry a big payload. But we sized it such with really big propellers that it's really efficient. So with a full payload, we were able to get up to 20 minutes of battery life on a single battery. In the future, we're looking to expand that either through a hybrid option or through a tethered solution. But at present, that battery you can swap out in a few seconds and keep going all day after a quick landing.
Does the design help in the drone's ability to withstand higher wind speeds?
In theory, yes. We're just getting started doing our flight testing. So we anticipate demonstrating that more and more. But that's really the main feature of the Cyclorotor. So if a gust of wind comes along, that Cyclorotor can near instantaneously compensate for that wind gust. So it should be much, much more robust in wind, and not only more robust to wind, but also able to operate more precisely with or without the wind.
As you mentioned, Cyclorotors have been around a long time. Can you give us a quick primer?
Oh, absolutely. The Cyclorotors are kind of odd and unique technical history associated with them. There were some designs in the 1920s of the Russians trying to do it, and a couple instances in Europe. But in the United States, it was a really interesting story. There's an illegal immigrant. This guy was a descendant from a German family who happened to end up on a German merchant ship. And in a stop in Seattle, this German sailor was drugged when he was on shore. And he was put on a ship to China to be like kind of a slave laborer. And he woke up on the ship with a friend, and they were able to escape before it left port. But now they were stranded in Seattle as illegal immigrants to the United States. To make a long story short, this guy ends up being really successful. He is able to get his legal residency and ultimately citizenship. He gets his degrees in engineering in Seattle, and then ultimately becomes a professor at the University of Washington. And as a professor at the University of Washington, he becomes obsessed with the Cyclorotor idea. And they do some wind tunnel testing of the thing back in the day. And he ultimately attracts the attention of William Boeing. So this is the guy who actually started Boeing Aircraft Corporation. And Boeing put a whole bunch of his own money into the project. I'll have to look it up. But it turns out to be, in today's dollars, about $2.3 million. I think it was about $100,000 at the time of his own personal money. And they founded a company called the Kirsten Boeing Propeller Company. They made two different types of propellers. One was supposed to go on airships of the time. This is the early 1930s. And they got this thing ready to put on the airship. They had it all ready to go with the Navy. But the airship that they were going to put it on, it crashed. It was named the Shenandoah. And it crashed on the way in a thunderstorm in Ohio. And so without any airship to put it on, the Navy kind of lost interest and died. Their other concept was for ships, and they actually made several, and they put them on some ships. I think one of them, racked up several thousand miles on the propeller. And the ship was pretty cool because it didn't have a rudder and it could turn around in place, and it was really maneuverable. But they tried to sell it to the Navy, these pre-war years, not on the basis of maneuverability, but on the basis of efficiency. And at the time, they didn't have enough research to really fundamentally understand, what went into making these things efficient. And so it was marginally less efficient than the propellers of the day. And so the Navy didn't take it, and it kind of died there. But other companies were able to successfully commercialize it for shipping. But in that particular instance, they were not. It wasn't really until fairly recently, I think 2008, 2009 timeframe, that the concept was repicked up by the University of Maryland in the United States under one professor, Indra Chopra. And they really looked at the fundamental physics. How do you make this thing much more efficient? And they were able to make a lot of strides. I joined their team as an intern, as an undergraduate, and then I took that research ultimately into my doctorate, where we, were able to translate this from being a fairly inefficient thing, left over from last century, to something that can be actually more efficient than a traditional propeller can be. But the main advantage, again, isn't efficiency, it's the maneuverability. So kind of an interesting story.
How did you come to realize that cyclorotors could provide a benefit in drone flight?
I was kind of a crazy undergraduate. I was really interested in general aviation and propellers, and I had a new idea for a different type of propeller that could be a little bit more robust in the event of an engine failure for small aircraft. And I bugged the professors at the Air Force Academy so much about this concept that they ended up putting me on another project, which was the Cyclorotor. They were interested in playing with the Cyclorotor. They've been playing with it as a wave energy device, and then they decided to try and put it on some aircraft. And I got obsessed with the idea and ultimately got an internship at the University of Maryland. And the University of Maryland had been using them to try and build micro air vehicles, so very small aircraft, that can fly into buildings and do rescues and things like this, sponsored by the Army. And the Cyclorotor is really good for those types of applications. It can be very efficient at small scales. So I worked on it there. We were building full-up drones that used the Cyclorotor not just for propulsion, but also for lift. So that kind of aircraft is called a cyclogyro or a cyclorotor. There's a company in Austria called Cyclotech right now that's trying to do that for electric VTOL aircraft. But we built several of those, among the first of those types of aircraft. But I saw, in the wake of all that research, that the true advantage of a cyclorotor is the maneuverability. So when we started considering how to commercialize the cyclorotor, we said, we really need to feature that strength of it. And talking with a bunch of different customers and a bunch of different audiences, we settled on the idea that if you could make a drone more precise to do robotic tasks, then you'd really have something. And the cyclorotor is a key technology that can enable that to occur.
When you talked about how it was to maneuver, it made me think of a hummingbird.
In our investment pitches, we always say, a traditional drone is kind of like a pigeon. It can fly, but it can't do so precisely or gracefully. And what we're trying to build here, what we have with Astria is a hummingbird, the ability to put something exactly where you want it, keep it there.
I also understand you're doing some continuing research with Boise State. Can you talk about that and how it fits into the evolution of the company?
Absolutely. We reached out to Boise State when I moved out to Idaho for my other job. And when we moved here, I saw that there was a grant from the state of Idaho called an iJam grant. It's an entrepreneurial grant to try and help commercialize technology that's coming out of the university. And we knew that we needed some sensors for our drones, some tools that could leverage this up close and touch-based capability. So we found a professor there, Professor Yang Liu. He's been tremendous. And he's an expert in concrete and the sensors that help identify problems in concrete. And he had been working on active thermography, one of the sensors that's now for our drone. And so we decided to partner with him and apply for an iGEM grant. And we weren't successful the first time around, but the second time around, we got $250,000 from the state of Idaho. And we hired a full-time employee. We hired several interns. And we not only built the entire drone platform, but also the active thermography sensor. And the state was so pleased with our progress, they actually gave us a $50,000 extension for a total of $300,000. And we've just loved working with Boise State. It's really fun to bring on interns and graduate students that have so much energy and innovation from the university level. And I love being able to fall back on the expertise of professors who are really well versed in the theory that goes behind everything. So that has really not only informed our sensors, but also helped to make our drone controls even better, even more precise. So we've had an awesome relationship. Moving forward, we're working with them to do a bird diverter payload. So to install those bird diverters on power lines, we're doing that in partnership with another company that does engineering for power lines. And the students are going to help us try and make a new payload to install those. That would be pretty cool.
Is the concept to have the Astria arm actually install the bird diverters on the wires?
Exactly, yes.
Because right now they're installed manually, right?
Yeah, and it's extremely dangerous. The lines are, upwards of 250,000 volts, and they don't turn them off to install the bird diverters. So they have to on small power lines use a specialized bucket truck and then a specialized device to try and, stick these things on the power lines without electrocuting themselves. Or in some instances, like on high voltage power lines, they have to actually hire a helicopter, and the helicopter has to fly close enough to the line where a guy can lean out onto a live electrical line to install the bird diverters, many thousands of dollars an hour. So these types of tasks, should be done by an autonomous or, a remote platform to make it a lot safer.
Where are things now with the company and the drone?
We're a developmental engineering company at this point. We'll look to start manufacturing these. Currently, we have done about 25 flights of the drone. And just a couple of weeks ago, we did our first up-close demonstration where we put a 5-pound payload within several inches of a target and held it there. In the next coming months, we already have some testing partners lined up from a variety of industries for bridge inspections, bridge engineering, power line inspections and engineering, and then some more general drone applications. And we're testing, try and test this drone with those different customers and get their feedback and take that to design something for the wider market.
If all goes well, when do you anticipate production of the Astria to begin?
Well, we should see initial tests with customers this year. And then I would expect to have the first level of this product go out with our initial customers for revenue sometime in 2023. So in about, probably 18 months is what I would expect.
Is this your first startup?
It is. Our startup has worked with some other startups, so we get a lot of experience from that. But this is my first startup company. We've had it going for a number of years, so I've sure learned a lot on it.
What advice would you give to other entrepreneurs?
I don't know, build a good team. We've been really lucky in that respect. You've got me on the show right now, but I'm the dumbest of everyone on our team. My co-founder, Ian Gibson, he was number 2 in our Air Force Academy graduating class. And he went on with a Marshall Scholarship to get 2 master's degrees in England. Then as an acquisitions officer, oversaw, hundreds of people in the acquisition of stuff for the government. And now he's getting even more experience at another medium-sized software startup. So he's just tremendous. Our CEO, David Bennett, he has 30 years of Air Force experience and 24 years of experience as a commercializer of research. So where he was doing the business development to take products and get them from the workshop to the warfighter, as he likes to say. So we've been really privileged to have that team. And so other entrepreneurs should form a strong team and then go take advice from people who have already done it before them.
Your overall team is comprised of several Air Force veterans. How has that experience played into the company's growth?
We're really proud that our whole team is Air Force veterans. Ian and I, the co-founders of the company, we both went to the Air Force Academy together. And David Bennett has been in the Air Force a lot longer than us. Ian was an acquisitions officer. David Bennett, he did a whole spectrum of jobs in the Air Force as an air battle manager. So someone who oversees aircraft from the ground in a combat environment, kind of a combat air traffic controller, if you will. And then he also was a cyber warfare squadron commander, and he also oversaw secure data links between the ground and our combat aircraft. So he really understands what it takes to make something secure and robust. And we're really proud to lean on him for those types of things. And we're proud to lean on Ian for his experience in acquisitions. I'm just a pilot. I fly the Strike Eagle F-15, but my background before that is all in engineering. So hope that types of things that we're putting our combat aircraft through, we can make sure that our platform is equally robust to put it in the hands of our customers going forward. But we hope that our veteran background provides some mission focus and the discipline to get the job done and get this thing out there.
Zach, is there anything that we missed that we should talk about?
Yeah, I know we mentioned how big it was, but despite its size, I think it's important to characterize that we've designed it to be able to get to the workplace. So, our customers wanted to be able to check it on the airlines and then put it in the back of a rental car to drive it to the work site. So the whole thing comes apart and it fits into a ski bag and then a couple of hard cases so that you can do both of those things. And it does so real easily. It comes apart in just a few minutes and it goes back together just as easily. That's a key feature that we've spent a lot of time designing too. That's pretty cool.
I also understand that nearly everything is manufactured or assembled in Idaho.
Exactly. So, one of the biggest problems in the drone industry overall right now for the customers is that the government has prohibited the use of these Chinese manufactured drones for the inspection of government assets. And so DJI isn't going to cut it for most of the commercial applications, since the government infrastructure and defense infrastructure is a large portion of those tasks. So you're having to essentially, these inspection service providers, the guys that are going out and flying these drones, need to find drones that are manufactured in the United States. And we've gone really to the ends of the earth to get everything on the drone as much as we can manufactured in the United States, and then put those components that are manufactured in the United States together right here in Idaho. And that allows it to be used for these really important use cases like bridges and towers and power plants and military infrastructure that other companies aren't able to access if they're using those foreign-made drones.
Yeah, I noticed the Made in Idaho stamp on the side of one of the components.
We're really proud to be from Idaho. They've been a great incubator for the technology. They've got great connections, and it's just a wonderful place. So we're really proud to have the company here.
And for my final question, Zach, what message would you like to leave regarding the future of the drone industry?
I'd like to ask people to recharacterize what they think drones can do in the future. While today we see them thinking of them as just something that can do inspections or just take video or just do security, in the future, I think we can start thinking them as flying robots, things that can go out there and actually do tasks that would traditionally have to be done by someone on a rope or a ladder that's putting their lives in extreme danger to do that. So drones are not just airplanes, and drones are not just surveillance platforms. I think we're going to see drones as take on tasks that people didn't have any conception that they could possibly do before.
That's it for episode 363 of the Drone Radio Show. I hope you enjoyed hearing from Zach Adams of Pitch Aeronautics. I want to thank Zach for taking the time to speak with me. If you want to learn more about Pitch Aeronautics or want to connect with Zach, check out the website at pitchaero.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.